Okay, college algebra. This is section R6. We started this flow chart yesterday. I'm going to add to that a little bit today. And we are right at the top of the second page of your notes where it says factoring trinomials. I'm going to go ahead, and you might have to be flipping back and forth on this. Let's go ahead and fill these two things in. Yesterday we said that if you have four terms after you do a GCF, you always want to look for a GCF first when you're factoring, something that you can pull out. And then after that, if you have four terms, you can do the factor by grouping method. If there's three terms, the two things that you're going to look for is a simple trinomial and a complex trinomial. And I'll show you examples of those down here in just a second. But a simple trinomial is three pieces or three parts. That's what makes them a trinomial. And simple meaning just x squared. Okay. Complex trinomial has three parts. He's still a trinomial. Okay. But he has like a number in front of x squared. Okay. So there's like that thing going on. All right, let's look at two examples of those. They first say right here, factoring trinomials. I hope you can hear this. Factoring trinomials is like the reverse of multiplication. So if you would start here, like you would FOIL this out to get this, factoring is going the opposite direction. So you're starting with this and you're trying to work backwards to get it to the two pieces. Okay, so I went ahead and I changed a couple of these because these were all complex trinomials and they didn't do any simple trinomials. So I changed these a little bit. So change these on your paper. Get rid of this in front of the y squared and then change this to minus 5. And then plus 6 at the end, and then go ahead for C also, get rid of the x squared, and then change this to a 7, so plus 7. And we'll go ahead and do those. Those are simple trinomials for each one of them because they're three pieces, 1, 2, 3, and they have just x squared or y squared as their first term. Okay, so what we're doing is, and I know we've done this before, you're looking to see what can you multiply together to give you this number, but when you add them, give you this number. Okay, so multiply to get 6, add to get -5, and I think that's going to be -3 and I should be doing y minus 3 and y minus 2. Okay, -3 and -2 multiply to give you +6, add up to give you -5. So this is what you want for your simple trinomial broken down. Okay, I'm going to go to C and then we'll bump over to the right side. This we're trying to multiply. Again, this is a simple trinomial, so there's no number in front of the x squared. I say there's no number in front of the x squared, that just means that number is 1. So there really is kind of a number in front of the x squared, but it's the leading coefficient or your value of a, they sometimes call it. A is 1 in this case. Okay, so we're trying to multiply to get -18, and we add, it give you 7. So we're looking for those. And if you get stuck and you don't know, like just start listing, factors. So 1 and 18, 2 and 9, 3 and 6, right? Which one of those is going to give you 7? And the combination is going to be your 2 and 9 combination. So x plus 9, x minus 2. And it doesn't matter which order you put those in. You could put them at x minus 2 first. Okay, those are simple trinomials. Now we go over to a complex trinomial. And this is where we have a number in front of our x squared, or in this case it's p squared. Okay, so complex trinomial, I'll write out the steps over here just in case you forgot from like way back when we did these. So step number 1, we want to take a times c. So that's the 6 times -5. 6 times -5 is -30. Okay, step 2, list your factors.
I'm not bringing any.
What? Hey, I'm recording, so what's up? You're just gonna sit here? What?
I'm gonna back
Okay, alright, sounds good. 3 and 10, I think that's it. 1 and 30, 2 and 15, 3 and 10. Oh, 5 and 6, duh. Okay, so I want to list my factors, and then the third step I'm gonna do is I'm gonna write my 4 pieces. Okay, so I'm looking for, if I multiply 6 and -5 together, it gives me -30, and the factors of -30 are here. I want whichever factors will add up to be -7, okay? So I think 3 and 10, and we know that since it's a -30, one of those has to be negative, and it has to be the 10 that's negative in order to be a -7, Okay, so now I do the hard part, which is writing the 4 terms. So I take this guy over here, and the first term, 6p squared, he's just going to like stay, right? And the -5, he's just going to stay. But this 7 breaks into 2 pieces. So I have 2 pieces here, and my pieces are plus 3p minus 10p, right? These 2 pieces are what my 7 breaks into, okay? And then the 4th step, the last step, is factor by grouping. By grouping. So just what we were doing yesterday, we group the first 2 pieces, group the second 2 pieces, and then I pull out stuff. So out of this first piece, I can take a 3 and a p, and left over is 2p plus 1. And in this group, I'm going to take out a -5, and left over is 2p plus 1. And I know I did it right because I have my 2 pieces that are the same. So I take out a 2p, and I don't remember who it was yesterday, maybe Aubrey was talking about this yesterday, and she's like, okay, 2p plus 1, there are 2 of them, so I should do 2p plus 1 squared, right? Well, the deal here is you have like this chunk right here and this chunk right here, and you're pulling them, like pulling it out in front. So you only have one of the 2p plus 1s, and then as soon as you take that out, you'll have 3p minus 5 left over. So you don't square this guy. You're just pulling him out in front of and taking him out of those 2 pieces. So that is that. That's how you do a complex trinomial. You kind of make him or like figure out how to get him to be 4 terms so that you can do factor by grouping. Okay, all right, so that's the same thing for part D, except we need to GCF first. This is a GCF and a complex trinomial. So let's look at this. I know that I can take out a y, right? I'll pull a y out front, but I can also divide everything by 8, I think. So I'm going to do that first. And if I do that, I get 2y squared plus 3y minus 2, I think, is what I get. Yeah. Okay, now this again here is a complex trinomial, and what we want to do is we want to take 2 times -2, which is going to give us -4, and then I want to list factors of -4, which are going to be 1 and 4 or 2 and 2, and those I want to get 3. So it's going to be the 1 and 4 combination. It's got to be -1 plus 4 in order to get a positive 3. Okay, all right, this 8y is just going to, well, yeah, that 8y is just going to chill for a bit, and I'm going to put him in brackets. Okay, so this 2y squared, he's just going to come down. -2 is just going to come down. And then this guy's going to separate into those 2 pieces. So -1y plus 4y. I got those from this guy right here. Okay. All right, now I'm going to group, and I'm going to group. And out of this chunk, I've got a y, and left is 2y minus 1. I'm going really fast. Sorry if I'm going too fast. You can always pause if you need to. I'm going to take a 2 out of here, so 2y minus 1. And I have that going on. Don't forget about your 8y here. Okay, then I'm just dealing with this stuff in here. This 2y minus 1, I'm going to pull him out. Left over will be the y plus 2, and I've got 8y on the outside. And that is done. Okay, so simple trinomial, complex trinomial. Those are my options for factoring trinomials or things that have 3 pieces. Okay, they give you like factoring perfect square trinomials. So sometimes you'll have the case where like when you break them down, like these 2 pieces will end up being the same, and you can write them as that piece squared or that piece squared, right? We'll see that here in just a second. So looking at A, this is another complex trinomial, and I'm trying to look and see if there's a GCF, if I can take something out. 16, 40, 25. I don't think so. I don't think so. Okay, so let's take, oh gosh, that's going to be awful. Let's take 16 times 25. I got to think of what that is. 16 times 25 is, I know 4 times 25 is 100, so this is 400. Hey, okay. 400. All right, I want to multiply to get 400, but when I add them, give me 40. Okay. Well, I can start with like 1 and 400, or 2 and 200, or 3 doesn't go in there. 4 and 100. That's not going to be anywhere near that. I'm up to like 8. 8 and 50. 8 times 5 is 40, so 8 and 50, we're getting closer. Like 10 and 40. Did I do that right? 4 times 400. 10 and 40, and it won't be that combination. 15. What's 15 in there? Sometimes you gotta think about some of these forms. Nope, 15 doesn't go in there. 400 divided by... Oh my gosh! Are you screaming at me yet? Bleh. Blah, 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 blah. How dumb. How dumb. 20 and 20. That was so silly. Are you yelling at me yet? They both have to be negative in order to be a positive 400. That was so stupid. Why am I being so stupid? I don't know. I don't know. All right, negative 20, negative 20. Bleh. All right, whatever. 16p squared. 25q squared. Those two just stay, but this guy is going to separate into pieces. Negative 20pq minus another 20pq. Okay. All right. Let's not be dumb here. There we go. There we go. Group, group. Okay. All right. Out of this, I can pull out a 4 and a p, and I think that's it. So I've got 4p minus 5q. Hey, okay. This guy, I'm going to take out a negative 5q, and left over is 4p minus 5q. I forgot my plus sign right there. So we have 4p minus 5q, and if I take that out, I have left 4p minus 5q, and that is going to be, if you want to write it as 4p minus 5q squared. There he is. Okay. All right. B is another one of these guys. I'll scroll back if you need to. Okay. B. Ugh, we got some huge numbers again. Anything I can take out? 49 is only 1 and 49 and 7 and 7, so I don't think I can take any GCF out. Darn it. Well, shoot. 36 and 48. Okay. Multiply those together. 36 and 48. 36 times 48 is 1728. Blah. Okay, just because I know how this is going to work, and I'm going to not be a dum-dum like I was before here, and I know that I'm doing a perfect square trinomial, these two middle pieces are the same number when we're doing it with a perfect square trinomial. So I know that if they have to add up to be 84, one has to be 42, and the other one has to be 42. Okay, so let's see if 42 times 42 gives me, nope, that's not right. 42 times 42 gives me 17. Did I write that down right? 1764? Good heavens. 42 times 42 is 1764. 36 times 49 is 1764. I wrote that down wrong. 1764. There we go. So 42 and 42, that's my combination. Just because I know it's going to be a perfect square trinomial from the heading, right? We are factoring a perfect square trinomial. That's how that works in the middle. Okay, plus 49 here. I've got 36x squared y squared. And, of course, these are my two pieces that add together to give me 84. All right, now I do my factor by grouping. Group and group. And out of this, I can take out 6. Yeah, I can take out a 6 and an x and a y. Ooh. Okay, left. 36 divided by 6 is 6. That will give me xy plus 42 divided by 6 is 7. And the xy are gone. So 6xy plus 7. Okay, out of this, if I'm using my context clues here, I'm going to guess that it's going to be a 7. And I get 6xy plus 7. And my two pieces are 6xy plus 7 and 6xy plus 7, or 6xy plus 7 squared. There we go. So fancy ones, if you can remember this formula, you can get to this part faster, but I just do it like a complex trinomial because then I don't have to memorize the formula. So I don't worry about another thing to have to remember. Whatever. Okay? All right, those were all your trinomial things. So on your flow chart, you get simple trinomial, complex trinomial. Sometimes you'll end up with perfect square trinomials. Perfect square trinomials. But I just factored those just like a complex trinomial. So whatever. Okay? All right, other things that have two terms. I don't want this video to be terribly, terribly long. So let's see, there are three of these. The first one is let me go in a different color. Difference of squares. Then we have a sum. All right, let's go difference of cubes. Difference of cubes and a sum of cubes. Oops, sum of cubes. Okay? Okay. Do I want to write down formulas for those? Yeah, I do. Yeah, I do. Okay, difference of squares. When you do a difference of squares, you will end up with x plus y times x minus y. Okay, that's what you end up with for a difference of squares. That's your formula for difference of squares. Okay, so write that down and then I'll show you what I mean for an example. And maybe you already know what a difference of squares looks like. Okay, so x plus y, x minus y, when you break it down. Here is an example for factoring difference of squares. These are all difference of squares. Whoa, fancy. Okay, this guy, you know he's a difference of squares if you can take the square root of both pieces and he's a minus in between. Okay, and so they come out really nicely. Difference of squares are just really fast and easy. If I'm looking for the square root of 4m squared, the square root of 4m squared is 2m and 2m. The square root of 9 is 3 and 3, and one of them is plus and one of them is minus, and then I'm done. Okay, that's a factoring a difference of squares. So it's that x plus y, x minus y, whatever x and y are, right? In this case, it was 2m and 3. Okay, so one of them is plus, one of them is minus, and that's how you break them down. Okay, let's go to B right here. Okay. Oh, heavens. All right. Square root and square root. All right. He looks like this. Okay. The square root of 256 is 16, I believe. Let me check that. Yep. So this will be 16, and the square root of k to the fourth is k squared. 16k squared. Okay, and the square root of 625 is 25, I believe. Yep, is 625. So this one's 25, and that is m squared and 25m squared. And one of them is plus and one of them is minus. Now, they were really all sorts of not very nice to you in that this guy is another difference of squares. He is not very nice. He's another difference of squares. So we want to break him down, all right? So I'll break him down over here. If I take the square root of 16k squared, that's 4k and 4k. And if I take the square root of 25m squared, he is 5m and 5m. And one of them is plus and one of them is minus. Now those are completely broken down. But now I want to make sure I put my 16k squared plus 25m squared off the front. This cannot be broken down because he's not a difference of squares. Difference means minus, right? He has to be a minus in order for that to break. Oh, why did I do that? Circle. So that's how that has to work. Okay. Let's save CDE for tomorrow, and we'll wait and do difference of cubes and sum of cubes, okay? But let me put one more thing up on your flow chart for difference of squares. When you're doing a difference of squares, you're looking for some things, some bullet points like these, guys. You're looking for a difference, which means minus, in between two values that are squared. Okay, so difference meaning minus between two things that you can take the square root of or that are squared, right? Difference of cubes, we'll write down those formulas tomorrow. I've got those. And those We will probably, difference of cubes is a formula that I don't expect you to memorize. He's not that hard to memorize, but difference of cubes and sum of cubes, they're very similar to each other, those formulas. We will write that down on a note card for for the test for this chapter. So I won't expect you to memorize those. So we'll finish those 2 tomorrow, and then your flowchart will be done, hopefully. Okay? All right. Go ahead and keep working on the homework assignments. As far as you can get, you should be able to get a little bit farther than where we left off yesterday. So there you go.